Hi and welcome. In this video we're going to take a look at light mapping in Unity. Now I was thinking about the best way to do this video, and in the past I have done a 5-minute tutorial on light mapping, and to be honest I don't think that really does the process justice, because lighting in its own right is kind of an art form, and it is a crucial part of the process, and everything kind of hinges on the lighting. It's a whole aspect to your game, so I really think actually a more lengthy tutorial on the subject is probably beneficial, just to help really understand some of the settings and leverage them so that your game can look its best. So if you haven't seen my previous 2 videos on the introduction to lighting, then check those out. It breaks down what type of lights there are in Unity and the light modes that are available: real-time, mixed or baked, because this video is kind of using some of those aspects. I'll try and cover them again just in case you didn't get the chance to watch those videos. But lots to get through on this one. Let's dive right in. So in Unity then, I just wanted to very quickly go over some of the scene, and just so you know what's going on with what I'm doing here. So I've actually found a free asset online. It was by Astrofish Games, and it's the Medieval series. And it was just like a free, I think it was the Forge, I think it was called, but I'll put a link in the description so you guys can find it as well. And all I've done, just to make things a little simpler for this tutorial, is just taken some of those assets and just put together this very quick scene here, so we can actually use something that's not my awesome cubes and a little bit more relatable. So as I said in my intro, I've actually done a light mapping tutorial in the past, and what I neglected to actually cover was what light mapping is. So it's probably important to go over what light mapping is first of all, before we look at actually how to do it. So what is light mapping? Well, good question. When you talk about lighting in general, if you were to take a really nice scene, if we were to try and recreate a really nice scene all in real time, then that's an awful lot of information that we'd have to try and calculate. If you think about it, we've got all the direct light, and then we've got all the indirect light bouncing around, all the shadows, and if we have to do that for every object, for every frame, then you can imagine how computationally expensive that is. You need a pretty high spec machine to be able to compute all that really nice graphics and lighting information every single frame of your game. So to optimize our lights and to get all the nice shadows and indirect bounce lights and direct light into our game and running, we need to do something called light baking. Now, light baking is a pre-compute pass that generates a texture when it's finished called a light map, and that texture then gets reprojected back onto our models to create the effects of illumination and indirect light and shadowing. So the pre-compute pass shoots out rays into our scene for direct light, shoots out rays for indirect light, and indirect light rays bounce around and come back and tell the texels, which we'll cover in a second, all the pixel information that it needs to accurately create the light map or the texture. So light mapping is a form of optimization that's going to allow us to have really beautiful lighting in our scene at runtime. So this scene at the moment has been baked, just to show you. See, if I turn off my direct light here, which is set to mixed, it makes no difference when I turn it off, because it's using the light map texture to illuminate the scene, to illuminate all the models. The texture is being reprojected onto our 3D assets to give the effect of illumination, shadowing and indirect light. So if I set this to real time and then go to my lighting window quickly, I'm going to go and clear my light data. So this is what the scene looks like when it's being lit in real time. You can see the lighting is quite harsh, the shadows very dark. We're just using the kind of, this is just the direct light coming from this one light source in our scene. We can move it around and find a nice angle to progress later on. But using this method, we're not going to get any of the bounce light, the indirect light. That's going to give it's going to give life to some of the darker areas and get rid of the harshness of the direct light. If we wanted to optimize our game and get the benefit of all the indirect lighting, then we were going to need to create a light bake. So let's go ahead, and if you don't have your lighting settings open, go to Window and then scroll down to, where is it? Rendering, and then Lighting, and it's going to bring up your lighting panel. Now my head's not blocking anything, which it normally is because it's quite big, but I've got it cutting off at the right point, so we shouldn't miss out any of the important stuff. So we're going to go through some of these, and hopefully at the end of this lesson you're going to have a really good understanding of what these settings are and how to leverage them to get the best out of the lighting in your game. So the first thing I'm going to go ahead and do is just kind of reset us back to how you'll probably be seeing it, and that's going to be like this. Everything's going to be grayed out, and that's because Unity is looking for lighting settings, which is kind of like an asset, which is going to contain all the information for this stuff here. So we can go ahead and we can click New Lighting Settings, and it's going to drop this down into the inspector, and mine's helpfully put it in a weird file. But we're going to go ahead and call this, you can call it whatever you want, Tutorial Light Settings. I'm going to put mine in a better place. I'm going to put it in Assets. Put it there for a minute. So we've got Tutorial Light Settings, and you can see it's generated up here in my light window, or my light tab. And everything is now open and ready for us to tweak. And all these settings are now going to be stored in this Tutorial Light Settings. If I wanted to make another one with some different settings, and I can create a different light settings, probably go to Create, and it's probably going to be on this list somewhere. There we go. See, lighting settings. I could create like really crazy settings, and these two can have different values which we can then just drag in. For a minute I'm just going to keep it on Tutorial Light Settings, and let's go down the list and see what we can do. So let's start at the top for what we're going to learn here, and the first thing we're going to cover is Bake Global Illumination. If it's not checked, then our lights won't contribute anything to the lighting in our scene, and you get a notification here. All baked and mixed lights in the scene are currently being overridden to real-time light modes. We want to enable baked global illumination, so the mixed lights and the baked lights are going to be considered as part of the light map for whatever light map mode we're in. And currently the lighting mode we're in is Shadow Mask. We've got a warning here. It says this mixed mode is not supported by the current render pipeline. Fallback mode is subtractive. So I'm currently using the universal render pipeline, and not all pipelines support all lighting modes. So with the universal render pipeline, you're going to be able to use the bake, indirect, and the subtractive, and you can see Shadow Mask is grayed out here. Shadow Mask is going to be available through the high definition render pipeline, and currently our two selections here can be used with a forward renderer, which is what the universal render pipeline is. It's a forward renderer, and the high definition render pipeline can be set to deferred renderer, which will unlock the Shadow Mask. So I'm going to go ahead and set my lighting mode to subtractive, and what that means is that mixed lights, so any light that's set to mixed, is going to contribute to baked direct lighting and baked indirect lighting for our static objects in the scene, so anything that's not moving. Our dynamic objects, so things like your player, for example, will get real-time light from our mixed light and cast shadows onto static objects in our scene using the directional light in the scene. And then we also have baked indirect, where mixed lights provide real-time direct lighting, while indirect lighting is baked into the scene. So it really depends on your situation and kind of what you need from your game and the assets that you have in your scene. But if like this scene, you've just got a load of static assets and then like a player that's walking around, then that will probably suit the subtractive mode better, because then all the static objects are going to have baked direct light and baked indirect light, and then the player is going to receive direct light real time from our mixed light in our scene, and then cast shadows on our static objects. This is going to be your most performant lighting mode. So we're going to go ahead and I'm going to leave it on subtractive. So next up we have our light map settings. This is what's going to be doing all the work and is very much going to determine how long your lights are going to take to bake and the quality of those light maps that get generated at the end. Now the Unity light mapper is a path tracer, shooting rays out into the scene, and the rays are coming back with all the lighting information that it requires. And we have a couple of options for our light mapper. We can use a progressive CPU or a progressive GPU, and for the meanwhile, Enlighten is on this list as well. You can see here it's deprecated, so this is a feature that's going to be removed in upcoming versions of Unity. So I'm not going to actually cover this. I think for now you only really need to know about progressive CPU and progressive GPU. Now the two kind of really do the same things, it's just where the calculations are taking place. So progressive CPU, it's all going to be done on your CPU, and the other option is progressive GPU, which is currently still in preview and will leverage the power of your graphics card to calculate the light. And you'll see in a minute when we start baking lights what progressive actually means. It's going to allow us to kind of move around the scene, and whichever angle we have in focus or whatever objects we're looking at will have priority during the bake, and we'll be able to see it kind of doing it in real time, which is really kind of cool. Now we have our samples here, which we're actually going to completely skip for a minute. These are going to determine kind of like your quality and also how long the light is going to take to calculate. These are tied to our light map resolution, and this is all controlled through texels. So what are texels? Well, this is probably the most important part of light baking and understanding the process. Texels is everything. So let's have a look how they work. So what are these mysterious texels that we talk of? Well, what I'm going to do is I've done a very quick bake, and now I'm going to go to the shaded, and here we can see various different kind of layers, if you like, for our lighting. So we could go have a look at see the bait light map, directionality, and albedo and stuff. I'm just going to go ahead and leave it on albedo and zoom in, and you can see on all of our 3D objects here, you have this checkered grid, these kind of grey and darker grey squares. These squares are the texels, and each texel that we can see here, each individual square, is a pixel in our light map. So in terms of baking our lights, what happens when we hit bake, when we hit generate lighting, and it starts to pre-compute all of our light, these texels send out rays. And these rays are controlled by these values here, the direct samples, indirect samples, and environment samples. So each texel that we can see here, each individual square, is going to send out 32 direct sample rays. But what's important to note with some of these is, with the direct samples, each texel will send out 32 rays per light. So if we have, I've only got one light in here, so it's only going to send out 32 rays towards that. Each square is going to send out 32 rays to that light. If I had another light in my scene, maybe like a point light, then to calculate the direct light for that, each texel would have to send another 32 rays out to that point light. So you can see how increasing these numbers could drastically increase the time it takes to calculate. So each texel, each square is sending out 32 rays per light for the direct light only. The indirect samples, so each square, each texel is sending out 512 rays, and they're going to bounce, they're going to go out in a random direction, and then it's going to hit an object, sample the surface color at that pixel, and it's going to send it back to the texel where the ray was shot from. And the amount of times it does that, so let's say we are calculating our indirect light, this texel on the ground right here sends out a ray, boom, hits this thing, this pillar, and it's going to bounce back and send information back from that color for the indirect light. This is also, the amount of times it bounces can be determined by the user. So at the moment our bounce is set to 2. So what's going to happen is our texel is going to send out the ray, it's going to hit this, boom, and then it's going to travel again in the direction, boom, and it might hit this, and it will come back and then back, and it will give this texel the values of the stuff that it's hit, and then it will be able to generate the right color for the indirect light. So the more bounces we have, the more information and sampling that needs to be done on each and every single ray. So that will again increase your render time. You might get an increase in quality, and it all becomes a balance then about getting these numbers right and seeing the quality you're getting back from your light maps. Now these texels, so you might think, wow, there's a lot of texels here, and well, yeah, you're not wrong. We currently have a light map resolution of 40 texels per unit. So texels work in unit space. So if I was to go ahead and create a cube, which by default a cube is 1 unit in Unity. I'm going to go ahead and reset this. Where's he gone? On my cube that I've made with a light map resolution 40 texels per unit, with this cube being 1 unit, there'll be 40 by 40. Kind of see how the texels are working here. I'm going to go ahead and delete that for a minute. So the time it takes for your light map to calculate is very much driven by the amount of texels you have, your light map resolution, and the samples that they are set to. The higher the numbers, the longer it's going to take. And the lower the number for the light map resolution, you'll start to lose quality in your lighting and shadows, but we'll see an increase in speed. So what I tend to do is start off quite low with my light map resolution. So let's say I want to just do like 10. You'll see here all the texel sizes adjust, and then each one of these texels is sending out 32 rays for our direct light, like so, per light, and it's sending out 512 rays at random to calculate the indirect light, and it's going to bounce twice. So let's say, for example, so everywhere at the moment is kind of, you can see the resolution that it's going to get in a light map. Areas with more texels will receive more space in our light map texture, and you can control how much texture a 3D object is going to get in our light map. So let's say, for example, there's something that's not very important that doesn't really need that much space in our light map. We can go ahead and click on it. You can see here it's selected this rock in our inspector, and the scale and light map is set to 0.25. If our player was getting quite close to this rock, you may want to set the resolution higher to something like 1. But remembering that each one of these texels is doing all the indirect and direct rays business. But we don't need that much resolution, and in order to speed up our pre-compute time, we can go ahead and say, like, the player's not going to get anywhere near this rock, let's set it at 0.1. And this one back here, the player's never going to see this. It's currently set to a scale of 1 in our light map, which is quite a lot of detail. We don't need that much detail, so we can set that to 0.1. And then you just need to kind of judge and gauge where your player's going to go, and control the size of, control the resolution of these individual aspects of your scene. So let's say, like, our player is definitely going to be going up this area here, and they're going to get really close to this rock. Scale of 1 in our light map is probably appropriate. As you can see here, this particular step only has a scale and light map of 0.5. Well, the player's going to be getting quite close to this, and we might want to actually set that to 1. But they're never going to see this object around here, these pieces of wood, because they're all hidden. And we still want to have them calculated, so maybe we can try 0.25. And going around your scene and adjusting these things is really going to improve your bake times. So that's definitely worth something to consider. So back in our lighting panel, we now know what our samples do, direct samples. Each texel from our scene is sending out a ray towards our direct lights. Our indirect samples, each texel in our scene is shooting out rays, random angles, and hitting things, coming back with information on the color. And it's going to do that. It's going to, the amount of rays that does is going to be driven by you, the user, and at the moment each texel is going to send out 512 indirect sample rays. And the amount of times a ray bounces can be controlled under the bounces section. So if we want to increase the bounces to maybe 3, so a ray come out from a texel, hit a surface, bounce off to a hit surface, bounce off to hit another surface, and then come back with the data. And we have an option just below called a Russian roulette start bounce. And now this is going to determine like a random number of when a bounce might terminate. So at the moment, if we were to set our bounces to say something like 3, and do that actually, set our bounces to 3, and our Russian roulette start bounce, a ray will be cast out and bounce, and then bounce again, and there will be the option there randomly for it to terminate at 2 as opposed to going all the way to 3 bounces. Filtering is something we can look at in a second. This is going to be looking at how our light map is kind of smoothed out and made all nice. But we're going to go ahead and do a bake in a second, and then we can look at those options. Light map padding is the difference, the spaces between the UV islands in our light map. You can actually see the UVs that these things are using by going up to our fading mode up here and dropping it down, and we can have a look at the UV charts. And this is really cool. This allows you to see all the UV charts on the light mapped objects. You can go to bake light maps and click on open preview. It's going to open a window that's something like this. So this is showing us where the object is selected in this light map, and the light map padding is going to be the amount of texels between UV islands, and these blue things are the UV islands. See the UV island for our little rock there, and the minimum padding it's going to have going to be driven by the value in our light map settings, which is currently 2. There's going to be a minimum of 2 texels between these UV islands. Max light map size, well, that's as if it would be for any other texture really. At the moment it's set to 1024. We can take it all the way up to 4096 if we wanted to, but for testing 1024 is probably fine. And we can go ahead and look at that, how that quality changes once we've done the bake. So just as a test bake then, let's go back to our shaded. And we're going to set our light map resolution to 10 texels per unit. And we're going to change, maybe we could halve some of these values. So each texel is only going to send out, let's say 15 rays per light. And the indirect samples, maybe we will only send out 200 rays per texel. Environment samples are okay, we can leave those alone for a minute. The amount of bounces, let's just set that to 2 for a second. So our indirect light bounce is just going to go 1, 2. Now light map sizes can be quite big. So I'm going to opt to compress my light maps. This will reduce the storage space of the light map, but it could also introduce a little bit of artifacts here and there. But that'll be something we'll have to judge once the light maps are baked. So with these settings, I'm going to go ahead and hit generate lighting, and let's see what we get. I'll go ahead and pause the video. There we are, my bake was calculated. It really didn't take too long at all actually for this scene, and you can see it's now generating my nice light map. It's only generated 1, which is fine. Oops. Going on here. Right, there we go. Only generated 1 light map, and you can see all the objects that I have marked as contribute GI in my scene as a part of that light map. So what do I mean by that? So when I hit generate bake, what's going to happen is everything in our scene that's marked as contribute for GI is going to make up part of our light map. So in your scene on your 3D models, if you don't have, to then click on the roof bit for a second, if it's not marked as static for contribute GI, then it's only going to receive the real-time direct light. Let's look at something else. So you can see, like, if we move this object, all the lighting information has been baked in, so the shadow will remain. This object has been marked as contribute to GI. However, our player is not. Our player is casting a dynamic shadow, and it's receiving its light from our directional light, which is set to mixed. This was set to baked, then this object would be black and the shadow would remain on the ground. But because we've got it as marked as mixed, and our player is not marked as contribute to GI, then it's going to receive the real-time direct light from our sun. And also we can be able to move our player, and it's going to cast a shadow across our static objects. So back to our lighting window. These settings look pretty nice. We'll go ahead and look at our albedo here. That's all cool. Texel validity, you've got some different options. Go ahead and look at our bait light map. This is going to show you where all the lighting is and all the shadows. So you have some very useful filters that we can look at some of this stuff in. Now we've baked our first light map and we understand the use of texels and how the samples are created and generated and calculated. We can start to have a look at some of these other settings. We can also turn on ambient occlusion, which is kind of like an artistic choice, and it's just going to create those dark areas around where areas are intersecting or are very close to each other, almost like contact shadows. The max distance is going to control how far rays are cast into our scene to determine if an object is occluded or not. I'm going to go ahead and leave all these at their default settings, and I'm going to hit generate lighting, and let's see the difference that we get here. You can see that that's darkened up some of the edges, and that'll be more noticeable when we increase our light map resolution. So the directional mode, which is directional or non-directional. With directional mode on, it's going to store all the directional data into our light maps. So if our objects have normal maps as part of their material, having a directional mode switched on is going to enhance how they look and make them look a whole lot more natural. So what do you do if you have an object in your scene that hasn't received any lighting? Well, you need to make sure that all your models that you use in your scene have light map UVs. If you haven't created the light map UVs yourself, and you can do that in your 3D authoring package, light map UVs are normally stored in channel 2 of the light map. Unity will actually generate them for you, so I'm just going to click on this mesh, and you can see here this is the FBX section for this particular piece. Now the UVs have already been created for this, but you could go ahead and generate your own. So you could say generate light map UVs and hit apply, and then Unity is going to unwrap the object and then put it on UV channel 2. And you have some settings for how these are all kind of packed, and you can go ahead and adjust those if you feel necessary. But you can see by me just doing that it's broken the lighting on there because we've reset the UVs, so that it no longer is in the same place in our light map. We would have to go ahead and rebake. Currently our shadows are very dark, and I know what the reason is for that one. In our scene, we also have, in our lighting settings, we also have, apart from all this for our progressive light mapper here, we also have a section for environment. Now this will depend on your scene. I have what would be an outdoor scene here, and I currently don't have a skybox, so I've taken it off just so I can work on my directional light. I would go ahead and I would add this back in, so I could go ahead and put in the sky, like so, and my environment lighting at the moment is just coming from a source color which is black. I can set this to skybox, so now my environment lighting is going to be controlled through the skybox. Then back in my light settings in the scene, when I do another bake, everything's going to, the environment samples are now going to be taken into consideration, and everything should have a much more natural feel to it because it's taken into account all the skylight, which is going to affect all the ambient light as well. So let's go ahead and bake it with the environment settings now configured. So there we are, that bake is finished. Now you can see the whole scene looks a lot more natural and outdoorsy because it's taken in all our ambient light from the sky. One thing you might notice is that it kind of looks kind of shiny, and that's going to be driven probably through the material. So on here I bet there's quite a high metallic, yeah, so you see it's got quite a high metallic setting. You can go ahead and tweak those materials. But now, because we've got all that skylight bouncing around, you can see it's really giving us some nice light inside our little hut thing here. And you can see it's also fixed when we change the light map UVs on this object for Unity to generate them, and it broke, you can now see that it's all been fixed again. So as an artist, I may be looking at this and thinking, well, my player's down here and my shadows don't look great on the floor. The floor could do with a little bit of love, so we could look at that and we see that the scale in the light map is 0.3. So if I was to go and turn on my bait light map here, you can see the texel density is slightly low for our player to be so close, so we maybe would set that up to 1 and instantly you can see how much more detail it's going to get. But also remember, all these texels are sending out all these samples, so it might increase your load time. But up here we could say, well, you know, player's never going to see the floor, we're not allowed up here yet. So we could turn this down in our inspector from 0.3 to say 0.1. Real balancing act actually getting all these things set right, but worth it in the end. Rather than just leave everything at 1 as a scale of 1 in a light map, you can really tweak and adjust these values and really get some nice light bakes really quick. Set mine back to shaded. Go ahead and bake it with the new value of 1 and see what we get. You can see now we've got a much crisper shadow on the ground. We're starting to get some detail from these smaller objects, and smaller objects never really bake very well anyway, but these are starting to have some influence and look really good. So lastly, I want to talk about, now we have a bait light map, let's discuss what some of these filtering options are doing. So if we take a look in our lighting settings, you'll see we have this filtering option which is currently set to auto. So what does filtering do? Well, filtering is a post-process to the light maps that effectively reduces the noise. And this is done using a variety of different techniques which you can fine-tune. So by default it's set to auto, we can click on it and let's have a look at our advanced settings and we can go through some of those. What happens with these 3 individual filters? We've got one for the direct denoiser, one for the indirect denoiser, and one for the ambient occlusion denoiser. And the light map is split into these 3 individual sections, and then the post process is carried out on each of them, and then it's combined again to produce the final light map. So you can see here, let's take a look at the direct denoiser. So this filter is going to apply a denoiser to our direct light part of the light map, and it's currently set to optics, which is an AI powered filter from NVIDIA. And you've got some other ones here too. All kinds of different filters, and what your machine can support will vary on whether any of these are actually available to you. The direct filter is either going to be Gaussian, A-true or none. Gaussian will effectively just create like a generic blur to all of the light map just to smooth it out and try and reduce the noise. A-true is going to kind of not blur the image so much when it tries to reduce the noise. And also, the way these two kind of work will differ slightly and give you slightly different results based on what one you choose. So Gaussian is just generic, and you might find some kind of errors with your lighting with the Gaussian filter selected. For instance, if we were to look at this over here, which should be quite dark, this shadow area here, with Gaussian what's happening is it's sampling the pixels all around it and trying to smooth it all out, which is generating an inaccurate result and can often make it look like sometimes an object's floating, where you might sample a bright pixel here and a dark pixel down here and decide that this is actually light when actually it should be a lot darker. The A-true filter is going to minimize the blur on the light map, and it's also going to be respectful of edges as well. And I believe those edges are determined by the UV islands in the light map. Let's just go ahead, and what we'll do is we'll change for our direct light and our indirect light, we'll change the filters to A-true, and let's do a bake and just see if we get any different kind of results. I'm just going to drop my light map resolution down so I can have a quicker render. I'll drop that down to 20 texels and hit generate light map. So I've just done my bake there with all my filters set to A-true, and you can see it's not blurred so much, and the accuracy is a little bit better, certainly in some of these areas where I was getting some funny brighter results and patches on the floor, but it's kind of produced a slightly better result. This is very much going to depend on your game, so I'll definitely recommend just playing with these filters and have a look and seeing what results you get and which ones you prefer. But the filtering essentially is a post-processing denoiser, which if you choose Optics, Open Image Denoiser or Radian Pro, they're all kind of AI powered. Have a play and see how you get on. One thing with our filters being set to A true is that we now have this value become available to us called sigma. Slider effectively controls how much we want to preserve the details and how much we want to blur the lighting. So just then, as a very quick recap, we've gone through an awful lot in this tutorial, and I know it's kind of long, but lighting is quite a broad subject, and it's good to have a good understanding of it. Essentially, we have our Unity has its light baking solution here, and it's the progressive light mapper, and you can have it powered by the GPU or the CPU. And by progressive, it means that it will do it kind of where you're looking in the scene. If you were to go hit generate lighting, it'll focus on the area and it'll bake out the lights and do all the calculations, and then as you move around, that's part of the scene will be updated. Our direct samples, indirect samples, and environment samples are very much tied to our light map resolution, which is the texels per unit. And remember, for lighting, really, texels are everything. And you can fine tune these by setting the scale of the light map for the models to an appropriate number, and that can really affect how much time your light takes to calculate. So if you take away anything from this lesson, it's going to be the fact that texels are important and how tied they are to the samples. Remember, each texel will shoot out 15 samples, 15 rays for the direct light, but it'll do that per light, so more than 2 lights, it has to effectively double that number. Indirect samples, it shoots out from the texel. My current sample rate is 512, so 512, a little tiny square on my charts here. Each one of these squares are going to be sending out 512 indirect sample rays that just come out at random and then hits an object, and the amount of times it bounces is determined by a bounce rate. Mine's set to 3, so it's going to go out, hit something, hit something, hit something, and then come back again with that pixel information. The Russian roulette start bounce is the random value that a light ray stops bouncing and comes back. And then the filtering is the post-process effect, the denoiser, which is going to smooth out our light maps, and you can control those using the filters for each layer, direct, indirect, or ambient occlusion. And then obviously, as I just touched upon there, we have ambient occlusion, which you can toggle on or off, and that is going to be an artistic preference. You don't have to have it, but if you think it looks better with it and gives those areas where there's some contact shadows or where things are close together, then that's going to make that appear a little bit darker, and you've got some settings there to control all of that. So I appreciate that's a lot to take in, and you might have to watch the video a couple of times. What I will do though is I'll post a link in the description, which is a link that will take you to Unity's talk they did on this at the Unite conference, and that goes over a lot of the same stuff, and to be honest, they explained it very well. So I would give that a watch as well if you've got the time, and that will help to reinforce some of the stuff I've told you. So for our scene then, let's go ahead and do a final light bake. I'm going to crank my direct samples up. Let's see how long this takes. If I was to say it's back to 50, I think it was on 50 by default. We'll leave my indirect samples at 512 and the environment samples at 256. 3 bounces is probably enough. I'm going to go for A true for all of my filtering apart from ambient occlusion, which I think I'm going to just do a standard Gaussian blur to that one. The sigma values are okay. Remember, that's a balance between how much blurriness we're going to have in our filter, or whether we want to preserve the details. Can I remember which side is which? That's probably more towards blurring the details, I would say. So I'm going to bring that back down to where that was there. Let's see how I'm going to go crazy and put my light map to 1496, and I'm going to set my texel resolution to, let's try 40. Light map padding is okay. We would only really want to adjust that if we're finding we're getting bleed in certain areas. I don't seem to be getting any, so I'm going to leave that for the time being. I'm going to leave the directional mode to directional, and all the other settings look a-okay. I'm going to leave it on also the subtractive mode for the lighting. Let's go ahead and do our final bake. Make sure we've got our lights that are set to baked or mixed. In my case, I'm going to do a mixed light, so my dynamic moving objects will benefit from real-time light from this mixed light. Then my static objects are going to have baked direct light and baked indirect light, and also baked shadows. So that's good to go, that light. And then we just cast our eye over our art assets and make sure that each one is set to contribute GI. And then when we're happy with that, we can go ahead and hit generate lighting. There we go. That didn't take too long at all. This is only a simple little level of only a few little models. And you can see you've got some really nice lighting there. Whoa, so that's it. So we've learned so much in this lesson. I couldn't even tell you what we've done, but hopefully you've learned a lot and you're able to now go away and light your games and feel confident in what some of the settings do. And you know, practice makes perfect. So just play around with them and see what works for you. In the next video, we're going to go ahead and take a look at lighting in the high definition render pipeline. And that'll be a cool one. So don't forget, if you're not subscribed, then please consider, because it really helps me out. And also leave a comment and let me know what you thought of the video. Thanks very much, guys. See you in the next one.